Are you ready for it? Okay, remember scientific notation, we're dealing with that. This says section 8.5, and that's from our normal book, because this book really doesn't cover it in a complete section. So a number with one digit to the left of the decimal point multiplied by a power of 10, that's scientific notation. So when we look at this, I have 9.27. Notice there's only one digit to the left of the decimal point. Another way to think about it is the number out in front here has to be in between 1 and 10. Has to be 1 or bigger. Can't actually be 10, so I guess it has to be 1 or greater and less than 10. So it could go like 9.9999. It can't be 10. You can only have one digit out here. Times 10 to the 6th. So the back part is just your power of 10. Okay, so when I'm looking at these first couple have been done for you. They're saying, hey, if you have this, you could, this 4,350,000. The decimal, when it's in standard form, which is what this is called, so maybe making a note to yourself, you circle this, call that standard form. It's the form we're used to seeing. Okay. The decimal, when it's in standard form, go ahead and tell your neighbor where your decimal is hanging out in this problem right here. All right, Bobby, where's our decimal hanging out?
No, you mean in the less than 10 or the...
No, in the 4,350,000.
On the far right?
On the far right, yeah. How many said the far right? I'm assuming Bobby means right there, far right. Yeah, that's where it's at. Okay, if you don't see the decimal, it's always on the far right. It's just hiding there. They don't show it. So in order to put this in scientific notation, you need to form a number that goes between 1 and 10, or you have to move that decimal all the way to the left in between the first two real numbers. Okay, so in this case, we move it 1, 2, 3, 4, 5, 6 spots to get to 4.35, and that becomes the number we write here. We drop all these zeros off the end. 4.35 times 10, well, did our 4,350,000, when I changed it to 4.35, did it get bigger or smaller? So is 4.35 bigger or smaller than 4 million? It's smaller. So my number went from a really big to a really small. It got smaller. It got smaller by 6 decimal places, right? So if your number gets smaller, your power has to increase. Okay, you're always starting at 0 in this case. So this is 4,350,000 times 10 to the 0 power, if you want to think of it that way. Well, each time you move it, you're adding a place value here. You're adding a power. So we moved it 6, so this goes up to 6. Okay, so if I was to move this, I would start here. And how many places? I'm not going to count by 1 this time. I'm going to use my commas. Every comma has 3 place values. So that's 3, 6, 7 places. Yeah? Oh, thank you. Okay, so we move it 3, 6, 7 places. So that gives me 9.3 times 10 to the 7. Okay. My number went from a really big, 93 million, to a really small, 9.3. So this power has to be a bigger power. Yeah?
And if it's a decimal, would you go negative?
So you're talking like this one?
Yeah, so if you go right, then it's negative.
Okay, I'm gonna avoid using the terms right and left. And there's a reason for that, because later on it'll become confusing to you. You're going to hear me keep saying, hey, if you start with a big number and you end with a smaller number, your power is bigger. So if the number you're dealing with is getting bigger, the power is getting smaller. If the number you're dealing with is getting smaller, the power is getting bigger. So like in this one, this is a really small number, like extremely small. Okay, I have to move this decimal from here all the way to in between which 2 digits? That's where you guys to answer. Which 2 digits does it stop with? Yeah? Between the 5 and the 6. Stops right there. Okay? So when I went from 0.000000563 to 5.63, did this number get bigger or smaller? It got bigger, which means my power, I have to go backwards from 0. I have to go down. So I'm at 0, -1, -2, -3, -4, -5, -6, -7, -8. Okay? So we went to 10 to the -8. So you should be able to look at a problem like number 12 and go, well, is my number going to get bigger or smaller? Tell your neighbor. Okay, now let me pause there because I saw about just a quick glance. When I said tell your neighbor, 6, 7 of you just not saying anything. You're like, oh no. Okay, that's unacceptable. You're in 9th grade. We should know if this number gets bigger or smaller. If not, you're not engaged enough right now. And I can't make it any more interesting other than like having you lay out numbers and move things around, which will take way too long for you. This should be pretty easy. Bigger or smaller, everyone? Okay, that wasn't everyone. Bigger or smaller?
Bigger.
It's bigger. Okay? If that's getting bigger, then my power of 10 has to get small. So how much bigger? Well, it moves how many places? 3. 2.46. So this has to go down 3. 10 to the -3rd. Okay? Very good. All right. So I want you to take some time right now, about 2-3 minutes, and go ahead and complete through number 20. Okay? You get till 46 after to get as far as you can. Okay, so checking those out, there's number 3 and number 13. I know that's kind of not in the numerical order, but notice on number 3, 7.214. So we want to keep all the digits other than zeros. Okay, times 10 to the 10th. Number 13 is 1.28 times 10 to the 5th. Number 4, 8.32 times 10 to the 14th. Number 14, 8.3 times 10 to the 4th. I guess you could actually have 8.3001 times 10 to the 4th is what you should have, because of that 1 way back there. Okay. Number 5, 4.927 times 10 to the -7. Number 15, 1.23 times 10 to the -7. Number 6, 8.5904 times 10 to the 13th. Number 16, 4.35 times 10 to the 5th. Number 7, 4.201 times 10 to the 4th. Number 17, 9.2 times 10 to the -5th. Number 8, 2 times 10 to the -1st. 18, 5.67 times 10 to the 4th. Number 9, 3.4 times 10 to the 2nd. And number 19, 5.4 times 10 to the 2nd. And number 10, 8.9 times 10 to the -5th. And number 20, 2.56 times 10 to the -3rd. Now, how many of you got all 20 of those correct? How many got 15 or more correct? Any questions of them, on them? What's that?
Aren't you supposed to actually write out the number on those?
Nope. Still want to go scientific notation. Yeah. So notice on number 20, it's not in scientific notation. Actually, let's actually put a problem up there with that. Number 20, it's not scientific notation because the front number is not between 1 and 10. All right, so we start our decimal here. We still got to move it. So we move it over from 256 to 2.56. Did our number get bigger or smaller? Smaller. So this, if this goes down, this one increases. So we got to increase it by 2. So that becomes 10 to the -3rd. Okay. And just like that on number 10, it's not between 1 and 10, so 1, 2, 3. Our number got bigger from 0.0089 to 8.9, so by power of 3, so that means this power has to get smaller by 3. So we subtract 3, so 10 to the -5th. Okay. Good question. Other questions there? Next thing we're going to do is number 21. I want you to do number 21 best you can. You get 30 seconds to try what you think you should do. All right. Someone want to tell me what they tried? Brendan?
Well, I got 6 times 10 to
Okay, so you multiplied 3 and 2?
yeah.
Okay, anyone else do that? Yeah, yeah, that's what we do. We multiply 3 by 2, and then so we multiply this by this. That gives us the 6. And then we multiply this power by that power. That gives us 10 to the 11. And since that's in between 1 and 10, it's 1 or greater and less than 10, we're good. Now some teachers will get really picky and they'll want to see it like this, scientific notation wise. They'll want to see you write 6.0. I'm fine if you didn't write that. Okay. All right. Well, let's go ahead and try the rest of those there. Best you can. Get 2 minutes to work through them. That's all we're going to get on this. Whether you're done or not, we're going to go ahead and just check them out. So number 22, 7.5 times 10 to the third. Number 23 actually becomes 2.4 times 10 to the negative 11. So you get 24 times 10 to the negative 12. But then you've got to change that to make it in between 1 and 10. So 24 goes to 2.4, which makes our power increase by 1. 24 is 1.2 times 10 to the 9. 25, 2 times 10 to the 9. 2.0 there. 26, 2.1 times 10 to the negative 10. And then 27, 2.6 times 10 to the negative 17. And the first 28, 4.5 times 10 to the 17. Any questions up to there? If you haven't tried the second 28, I want you to do it right now, please. Okay. That would be that 3 times 4 times 10 to the 5th and 5 times 10 to the 3rd. Okay. So we multiply 3 times 4 times 5, which is 3 times 4? 12 times 5? Yeah. 60, thank you. 60. And then 10 to the 5th and 10 to the 3rd is 10 to the, what about 10 to the, let's go 8. Okay, and so we have 60 times 10 to the 8th. What's wrong with that? Annalise?
There's 2 digits in front of the decimal.
Good, yeah. You got 2 numbers behind or in front of the decimal, so we got to move that over 1, which makes 60 become 6, which is smaller. So this got smaller, so this number gets bigger. 10 to the 9. Okay, 6 times 10 to the 9. Jaden?
How have you got the 10 to the 8?
10 to the 8, 10 to the 5th, and 10 to the 3rd. So same base, you add the exponents. Yep. All right, very good. Okay, next page. Taking a look at the back, we're going to just do the odds on the back. Okay, but what I want to talk about on it real quick, I don't want to spend tons of time, but if we're doing this first one, if when you're multiplying, you multiply the rational part, and then you multiply the powers. When you divide, you just divide. Piece by piece. So 1.8 divided by 6 is 0.3. And then 10 to the 5th divided by 10 to the 3rd. What's that? 10 to the 2. Yeah, 10 to the 2nd. Tell your neighbor if that's an okay answer. Scientific notation wise. All right. What's wrong with it? Okay. Yeah. Less than 1. It's got to move over 1. So that gets bigger. So we get 3.0. If that gets bigger, this one gets smaller. Times 10 to the 1st. So 10 to the 1st, we could write as 10 or just 10 to the 1st. Really, that's, you wouldn't probably use scientific notation as much there. But okay, why don't you try the odds? Okay, 31, 33, 30, and so on. We'll spend about 3-4 minutes on it. All right. We're gonna check these out here. Okay, so we're not turning in Bobby, but I will think highly of you for doing those extra ones. Okay, number 31, 5 times 10 to the 19. How many got it? Oh, a couple. Not too many. Some of us don't want to raise our hand. 33, 2.5 times 10 to the second. What's 35? Come on, man. Someone step out. Cole? 2 times 10 to the 17. Very good. 37. Anyone get 37 there? Someone new? Caden?
Isn't it 1.5 times 10 to the 22nd?
Okay, anyone second that? 1.5 times 10 to the 22nd. Well done, Caden. Good. Okay, and number 40 or 39, 1.5 times 10 to the negative 26. And then the last one, 41, you got to divide 3.6 by 9, giving you 4, or actually gives you 0.4. Okay, yeah.
How did you do 33?
Okay, let me finish this one real quick, okay? So we get 0.4, and then we've got to move our decimal place. So rather than 10 to the 5th, we get 10 to the 4th. Okay. Whoops. You guys once again didn't see that. All right. So number 33, the question came up. Is 7 divided by 2.8? Okay, so if you divide those out, does that give you 2.5? Yeah? Okay. And then 10 to the 5th divided by 10 to the 3rd is 5 minus 3 is 2. Okay. Any other questions there? All right, scientific notation, rate yourself 1 to 5. All right. So it's yourself, it's not everyone else. All right. Make sure you're asking questions if you need help on that today. Okay? I'll hang up these answers back up on the board if you want to look at them.